Alright, so we were on this slide last time, so let's go to the next one. So this is the definition of power. It's the rate at which work is done, and it can be measured, as I said earlier. The usual units for power is work in joules divided by time in seconds, and it's also measured if we do it in pounds per second. That's measured in units called horsepower, the old English units. So let's do an example. Alright, so here's our first example. Let's say we're pushing a lawnmower. Again, my drawing is terrible, but we're pushing a lawnmower. Let's get the wheels about the same size. And when we do so, you're applying a force, and there's actually, it turns out for forces, if you're pushing a lawnmower at some angle, you can break the force into components. That is, a horizontal component and then a vertical component. So that's what's represented by this downward force right here. And of course, you're pushing the lawnmower along, let's say, a flat lawn, and we move the lawnmower a distance, let's say a distance d. So it's going from here to here, and we measure that distance d to be, I don't know, let's say, just for simplicity, 5.3 meters. Alright, so that's the distance, and we're going to measure these forces. So the horizontal force, the force that is perpendicular to this distance, we'll call that F horizontal, is let's say 100 newtons. 100 newtons. And the downward force, that is the vertical force, F sub v, I'll call it, is measured to be, let's say, 35 newtons. Alright, and so we want to measure the work done. So we'll do the work, and then we're going to do an example with power, reminding ourselves, of course, that power is the work in joules in this case, divided by the time in seconds, and the power will be measured in watts. All right, and so here we go. So there's two forces acting on this lawnmower, and the first one is pretty simple. We'll take the vertical force first. So the work due to the vertical force is 0. And why is that? Because the vertical force here, right here, here's the vertical force. It's going down, and yet the lawnmower is moving horizontally. So since they're perpendicular to each other, the work is always 0, and that's always the case. And then the work done by the horizontal force is going to equal 100 newtons. Remember, work is force times distance, but they have to be parallel to each other for any work to take place. So it's 100 newtons times, in our case, 5.3 meters. All right, and that's of course going to be, of course going to be 530, and it's newtons times meters, which are better known as joules. All right, so that's the amount of work that's done by this horizontal force over here. And as we already said, the vertical force is 0. So what about the power? Well, we need to know one more piece of information. Suppose the time it takes to move this 5.3 meters, to move the lawnmower 5.3 meters, is measured to be, I don't know, how about 2.9 seconds. All right. And so once we know that, we can work out the amount of power. And of course there's zero power for the vertical force, because there's zero work done by the vertical force. So the power is all coming from the horizontal force. And so let's move that out of the way. So the power is equal to the 530 joules divided by the time, which is in this case 2.9 seconds. And so that power will come out in joules, of course. Alright, so I get, let's see, 182.8, let's say, so 182.8, and that's watts. And of course, so let's say that's, part A of the problem. If part B asked what's the number of horsepower, so we want to know the number of HP, the conversion factor is, of course, 1 horsepower is equal to 746 watts. If you look at the back of the front cover of the textbook, that'll be in there under energy. And so let's convert this from 182.8 watts to horsepower. Right? So the power is equal to 182.8 watts. And we know that there are 746 watts in 1 HP. Notice the order of the fraction. The denominator has the watts so that we can cancel watts right there. And so you just take 182.8 divided by 746, and let's see, divided by 746 is about 0.24 horsepower. Okay, so there's a nice example with horsepower and work.